Let's talk about the possible relationships between two lines in space. In three-dimensional space, two lines can be equal, parallel but not equal, intersecting at a single point, or skew. Lines that are skew are not parallel, but they do not intersect either. The relationship between two lines is determined by answering two questions. Are the direction vectors parallel? And do the lines share a common point? The table tells us that the relationship between the lines is uniquely determined by the answers to those two questions. If the lines share a common point, they are equal if they have parallel direction vectors, and parallel if they do not. If the lines do not share a common point, they are parallel but not equal if they have parallel direction vectors, and skew if they do not. In this question, we are given two lines that are described parametrically, and we are asked to determine what the relationship is between them. That is, are the lines equal, parallel but not equal, intersecting, or skew? Recall that when working with the parametric equations of a line, the coefficients of the parameter a, b, and c for each of x, y, and z respectively give the direction vector a, b, c for the line. So the first thing we want to determine is whether or not the direction vectors are parallel. The first line will have the direction vector v1 equals 1, negative 1, 4. The second line will have direction vector v2 equals negative 1, negative 2, 1. Clearly the vectors v1 and v2 are not parallel vectors, so the lines are either intersecting or skew. So now we need to determine if there is a point x, y, z that lies on both lines. We use the equations to create a system of equalities by setting the two expressions for x equal and likewise for y and z. If we can find a solution of the system that satisfies all three equations, then our lines intersect. Otherwise, they are skew. So our system is s equals 8 minus t, 5 minus s equals 6 minus 2t, and 3 plus 4s equals t. Since the first equation is solved for s in terms of t, we can substitute for s in one of the other equations. Let's substitute into the third. We begin with 3 plus 4s equals t and substitute to obtain 3 plus 4 times the quantity 8 minus t equals t. This can be solved for t to obtain t equals 7. We can substitute this result back into the first equation to obtain s equals 1. Now, if these two lines intersect, then the third equation must be satisfied by these values. So let's see if it is. We substitute 7 for t and 1 for s. 5 minus s equals 6 minus 2t, so 5 minus 1 equals 6 minus 2 times 7, which simplifies to the contradiction 4 equals negative 8. Therefore, the system of equalities is inconsistent, and there is no single point that satisfies all three equations. We conclude that the lines are skew.